So when these timpani were built in 1957, they used cast steel. A lot of newer timpani, I would say mid-60s or 70s and later, used aluminum casting. Steel and aluminum are very different in the way that we deal with machining, bending, fabricating, all that stuff. In this case, I heated up these mounting tabs to red hot, which allowed me to bend them to fit the suspension ring. And you can see when you look closely, when I get a good bend, there's actually some material flaking off. That is called scale. And you've seen that before when I made the tuning gauge parts and twisted the little levers that had a 90-degree twist in them. But as I heat this up red hot, it makes it just soft enough that I can manipulate it to fit the hoop better. You can see how the tabs just don't line up correctly. And by getting these to fit better, we're removing potential springiness, if you will. So if I clamp two parts together that don't quite line up, it's going to create some stresses or tension, and that can make a hoop go out of round, not be flat or level, and that's certainly something we want to avoid. Now on a different set of timpani where the ring is already attached, this would have a different approach. So keep that in mind if you're watching this to learn how to align timpani frames. This is not necessarily the same process that we would use for existing connections. I'll make another video about that in the near future. So other than the ability to bend the tabs, heating up the casting like this actually allows me to normalize the weld material that I use to plug the holes. Also, I can kind of shape it a little bit better, kind of round the edges over without it looking sanded. So it looks more like it's a cast. Alright, 7 of the 8 are done. The 8th one I'm going to leave alone because it looks good. Next step, let this cool down enough that I can come back, wire brush it, put some paint on it, take it back to the shop, and get the ring installed. Now before I heated these tabs up to red hot to bend them to the hoop, I had to actually get the struts aligned correctly. And I roughly, when I say roughly, I mean to within a 32nd of an inch, I got them all lined up where I wanted them. So I don't need to show that process because I'm going to do it again to get these precisely where I want them this time. So essentially what I need to do is rotate the strut so that the tabs are 12 1/8 of an inch away from the center post here, this jig post, which 12 1/8 times 2 plus 1 1/4 gives us 25 1/2, which is the outer diameter of our suspension ring. So once I have the tabs where I want them on the outer diameter, I then use the plumb line and the laser to get the strut actually plumb. And that usually involves shimming one side or another. And I can use shims to make things move pretty significantly. 3/1000ths of an inch of shim material will actually give me approximately a 1/16 of an inch of movement at the top. So if I have, for instance, you'll see a couple shots where the laser is off by maybe 1/4 of an inch. I would use 12/1000ths of shim material, or that's a good starting point. Put it underneath the strut in that flat spot that we milled on both the strut and the base casting, which then allows me to get it right where I want it. In the end, I'll use Loctite to permanently set these cap screws when I have these where I want them. And today I'm actually using a Loctite brand number 277, which is originally intended for larger bolts, but the aspect of the 277 that I'm after is the longer working time. I have another Loctite that I'll use on the rivets, and I'll show you that here in a bit. But the 277 allows me to move this strut and loosen the bolt and tighten it again over the span of about an hour. I need that amount of time to get things all where I want it and permanently tightened down. The reason we want these struts to be square or plumb is because if you think about force coming down directly on this Y, if this is leaning, say, this way, and we put force on it, it's going to make it want to go down like that. With the way this is set up being plumb and even all around, hopefully that ring will keep the struts together, so when we put force on it, it wants to go evenly like that, and it doesn't actually flex. So the common problem is when the strut is curved or tilted towards one direction, the entire frame will end up kind of rotating or flexing downward when we put a lot of force on it. We can eliminate a lot of that by doing what we're doing now, which is plumbing these struts, getting everything solid and tight, including the tabs at the top. We don't want any room for movement. We want this to be as stiff and as plumb as we can get it. So what I'm doing is getting this set from here to the center of the cap screw, or at least as close to the center as I can. And if this is all plumb and level correctly, it'll land in the same spot on each cap screw as I rotate around. If it's out one direction or the other, it'll hang differently. I know I can rely on that because I put those holes there. They're all 15 inches on center. I would say it's very close to being center, but it's slightly favoring the inside. So if it's favoring the outside of the opposite side, I know that I need to plumb it one direction. So being super, super picky here, I could go that way. I mean, just so much it's not necessarily worth it. But it's better to be picky now than to have complaints later. So now we're still favoring this side, but let's see if it's even when I rotate this around. I'm not going to move the camera, but we're the same on both sides. Double check it with the level. Looks good. So I like where the plumb bob is showing evenly on all the cap screws. To me, that means this is plumb. Everything is locked, or at least it is now. Everything is locked down. This plumb line is plumb. If we get a laser that is also plumb to split this, we know that we're going at a straight angle from the center of this post out past the string. And then we can plumb this. Now, because it's a casting, nothing on it is really flat other than what we've machined. We kind of have to eyeball what center looks like. It's kind of an averaging game. But by doing that, we might prevent the entire drum from kind of twisting or flexing when pressure is put down on the suspension hoop. So if I push pressure straight down, and we have a leg or a strut that goes 90 degrees, it's going to hold up the best, just kind of like the letter T. Whereas if I had something sideways like this and I push on it, it's going to hinge downward. And that is going to be a hinge point. So to avoid that, again, this is why I go through the trouble of getting all these aligned like this first. One of the keys to this system is that the laser be self-leveling. Right as it starts to get super bright back here, it starts to split the string line. Now I actually have two laser lines. So again, my laser line is splitting the string. It's coming straight down the string line. I see this as really well plumbed. So right now I don't need this anymore. So my measurement here is 12 1/8 on the plus side. So if I get these tabs 12 1/8 from the center and then need to bring it over, it's easier to rotate like this. So if I put a shim on this side, it kind of rotates it up. That one's good to go. Now I say it's good to go, but when I put the ring on, I may see a different story. We'll see. Got my double laser, follows the string line down, and it appears that this strut needs to go that direction ever so slightly. I'm getting 12 1/8, 12 3/16, and I want to bring it this way to get that even, so I'm going to end up throwing this even farther out of plumb. Alright. So now I have 12 3/16 on both tabs, and we can see that the plumb line is over on this side, so what I need to do is bring the entire strut this way and this way. Now right now I already have shims under there, so I'm actually going to remove some shim to get it to come up that way. And after I remove shims, we get the laser line to split it. I'm going to see if our measurement's the same again. 12 and 3/16, 12 and 3/16. That's good. Now I need to add some in to get it to go in ever so slightly. And this will go on the outside. There we go. So now that these are all 12 1/8 from the jig post, it's time to try the suspension hoop, see how it fits. And if anything doesn't fit quite right, I need to make those adjustments. This is sitting wide, this is sitting narrow. I need to work on this some. I said earlier I didn't want to, but I was wrong. From that perspective, you're gonna see me take this particular strut and bring it up and in like this. It's even from tab to the center. However, it needs to just be shimmed up. I'm still gonna set up the laser. So again, what we're using the plumb bob for is actually to align the laser. So at this point, I'm happy with how the struts are lined up. They're all plumb. None of them are pushing in on the hoop, nor are any of the tabs not touching. And that means it's time to get the hoop clamped. And to do that, because there's only one of me, I'm gonna add a clamp to two opposing struts that will just hold the hoop. Then I'll get it roughly aligned. And one thing I want to remember to do, and I even wrote a note on my jig here, is to make sure that the height is similar to the other drum. The other drum came out to, what was it, 28.5. I'd be happy with plus or minus 1/2 inch, so that way the drums are the same height when they're sitting next to each other. So I'm just eyeballing everything at the moment and very lightly clamping it. I don't want to clamp it so hard that we bend anything. And right now I just want to get it roughly level. One thing I have to keep in mind, and this isn't necessarily an issue on drums with existing hoops, is where this tab comes up to the suspension hoop, I need to make sure there's room for the copper lip to actually fold over. So we're 28 3/4, and actually that is exactly what I had on the other drum. Although it's not vital that these both be the same height, it's just a nice thing as a player to have the timpani be at the same position. And on the 28, I had to put the tabs really close to the bottom of the hoop. In fact, I had one spot where I have to repair the tab in the hoop because I drilled half a hole. With this, it's the opposite problem. I'm farther up, and that's because the struts are actually the same length for both drums. Just got the laser getting to the top of the hoop. I have a couple adjustments to make. Take a brass hammer and just barely touch things to get it where I need it. So at this point, the ring is clamped on where I'd like it to stay. The struts are plumb and aligned. All the tabs are touching everything. It looks and feels really good. There's no springiness or flexiness. The next step is to drill the holes for the rivets and rivet at the same time. So I'll start with a 7/64 cobalt drill to get through the hard surface of this tab, and then go up to a size F drill bit, which is 0.255, so 5/1000 over a 1/4 inch. And then drill from the back side with a slightly larger drill bit so that it kind of countersinks or goes back farther into the hoop. because you'll see once I get the bowls refitted to this ring, they're very flat-sided. There's not a lot of clearance behind here. So you might be asking, why rivets? Well, two reasons. One, they're really simple to install. I drill a hole, I take a rivet gun, put the rivet in, pull it, it grabs this little nail on the back side and pulls it all the way through. And that's a very permanent way of attaching things together. I'll put some Loctite on this end and on the rivet body. That way it will never vibrate loose. But not only are they easy, they're actually more precise. So if I needed to thread the ring and drill holes in the tabs, I'd have to drill a hole like I'm doing for this, then take it back apart so I could thread the hoop and make the hole the correct size for the fastener. It's more steps and it'll actually lead to less precision because every time I break this down, it's going to change the next time I put it back together. The same idea is used by machinists, or rather machine makers. Machine builders would use taper pins. In fact, that's what was holding together the pedal to the shaft and the cam to the shaft when I took these apart. So it just makes it easy to hand drill and run a reamer that has a taper to it and put it together in situ, as it's called. So what this will allow me to do is to drill a hole, rivet, be done. I don't need to do anything else. Now in the end, I may end up grinding a little bit off the backside to make sure the timpani bowl will fit. That'll be on another episode and we'll get to that. So let's get this done. Dab there, 2 or 3 dabs. And this doesn't take a whole lot. Put this in there. Looks good. And that one is done. It's nice and tight. Only sticks out about maybe 1/8 of an inch on the inside. Which again, I may need to grind that down just a little bit. Now that we have 2 opposing rivets, this is the last chance to get things level this way. And I think while doing this, it's going to end up shimmying things around. So I'm always going to recheck. And I think this side needs to come up a little bit. If you're worried that I'm going to go through my hand with the drill bit, it's far enough back these bits won't go through the larger bits. If I did this, I'd have a holy hand. So the frame alignment is done. There's still a couple little things to do to finish up, such as cutting the shims, and that's just a razor blade. That'll take a few minutes. I may wait until the Loctite is fully cured before I do anything down there. The struts are plumb, they're lined up where I want them. The suspension hoop is dead flat on top. It's centered on the casting using the jig. I'm happy with how everything turned out. The rivets are tight, the tabs look good. The next step is bowl work. And to see that, I hope that you'll tune in the next time I have a video come out. I'm also working on counter hoops. That's going on kind of slowly in the background. Eventually that episode will come out. To know when those all happen, like and subscribe. Maybe leave a comment if you have questions about frame alignments or you want to just offer something up. I'm hoping to do another alignment video in the near future using the floodlights. If you're unfamiliar with what I'm talking about, check out my blog at blog.dkpercussion.com. Thanks for tuning in. See you next time. Thanks for watching.